Hello, my name is Vatsal Parikh, and I'm going to present a paper on cryptocurrency price prediction using Twitter sentiment analysis. The cryptocurrency ecosystem has been the center of discussion on many social media platforms. Frequency of cryptocurrency related news and social media posts, especially tweets, is increasing quickly along with the economic and societal impact of cryptocurrencies. Similar to traditional financial markets, there appear to be a link between media attention and the cost of cryptocurrencies. While there are many factors that influence cryptocurrency prices, it is crucial to investigate whether sentiment analysis of publicly accessible web media may help forecast whether a coin's price will increase or decrease. Twitter is rapidly being utilized as a news source and a medium for Bitcoin discussion. This paper seeks to use historical prices and sentiment of tweets to forecast the price of Bitcoin. But what is Bitcoin? A virtual currency created for payments where the sender and recipient cannot be identified is called Bitcoin. The volatility of Bitcoin is 10 times that of major exchange rates. There are numerous reasons for this volatility. Google Trends, total circulation, consumer confidence, and the S&P 500 index are just few of those. So the main focus of this paper is to create an end-to-end model that can forecast the sentiment of a set of tweets and forecast the price of Bitcoin using the predicted sentiment and other metrics like historical cryptocurrency price data, tweet volume, a user's following, and whether a user is verified. Price prediction of cryptocurrencies using sentiment analysis is a culmination of two separate processes. The first process is sentiment analysis. Sentiment analysis can be done using two methods, rule-based or using machine learning techniques. The rule-based method uses a lexicon of words and stated rules to classify tweets. Vader is an instance of lexicon and rule-based sentiment analysis that requires no training. Machine learning techniques, on the other hand, analyze tweets based on algorithms like random forest, support vector machine, etc. The second segment involves price prediction of highly volatile cryptocurrencies. They use GRU to forecast BTC prices, Bitcoin prices. Here, GRU is an RNN variation developed in a way to get around the issue of vanishing gradients, and it has always exhibited dominance in time series predictions. The basic workflow of GRU is identical to that of a basic recurrent neural network, except that they have gates that regulate the current input and the prior hidden state. Finbert is used here for sentiment predictions and hence evades direct usage of a rule-based approach like Vader. They, however, use Vader to label the dataset with a composite sentiment score. This project consists of three parts: collecting the data streams and collating it into a single cleaned and comprehensive dataset, passing the tweet data through the BERT-based sentiment analysis model, and then finally using GRU to focus prices using the sentiment extracted in the previous step as well as other features. The dataset used for our work consists of two data sources. One data source is historical price data of Bitcoin extracted from Yahoo Finance. The columns used for model creation are high, low, open, close, and adjusted close, not the volume. We are only using these five columns. The second part of the dataset used is an open source dataset from Kaggle. It is a dataset that is daily updated and consists of real-time cryptocurrency tweet script. The used data is from 5th July 2021 to 4th August 2022. And the total size of the dataset after combining both of these datasets is 1.9 million. The sentiment feature was not natively present in the dataset, so they use Vader to manually label the dataset. As stage 1, they use pre-processing to clean the data, created train and test samples. Then in stage 2, Finbert is used for sentiment prediction and softmax is used for output layer, so the prediction is a probability distribution between 0 and 1. Then GRU is used for price prediction in stage 3, and then the experimental results are compared for each method using mean absolute percentage error in stage 4. Here, real-time testing involved scraping a stream of tweets corresponding to a particular set of daily prices outside a dataset. Predictions were made for two time periods: 5th August to 5th September 2022 and 5th September to 5th October 2022. GRU showed in first table is used for sentiment prediction so that we can compare it to Finbert, but it's not the same GRU used in price prediction. By LSTM is also used for comparison here. Both LSTMs and GRUs are similar in structure and are both used for solving the vanishing gradient problem posed by RNNs. The usage of Finbert in sentiment analysis gives very high accuracy. The error for the sentiment prediction using Finbert for the real-time and test data averages to 9.85%, and the error for the price prediction using GRU is only 3.6%. We can see the difference between the actual price and the predicted price in the graph, which is very minimal. My criticism with the paper is that while the authors acknowledge that cryptocurrency markets are highly volatile and influenced by numerous factors, they don't explain why sentiment analysis is a particularly useful approach, especially given the limitations of sentiment analysis in general. Also, this paper does not compare its method to many approaches for predicting cryptocurrency prices. This makes it difficult to assess whether their approach is truly novel or whether it's just a variation of existing methods. I'm using sentiment analysis in my final project and I'm working on part 2 for classification of tweets. So this paper is very close to what I'm trying to achieve. I learned a lot by researching about various models in this paper and will definitely try to implement some models and methods in my project. That's it from me. Thank you very much.